Okay, good morning. Good morning, everybody. I hope that people online, let's do in this way also. Can you hear me? Can you hear me? Yes, I think yes. Okay. I hope that also people online can hear me quite well because we have a horrendous background noise. Will be difficult today, I think. But anyway, so we'll do it. So for the people that are in the room here, we need to, from now on, to check your presence. You registered here for using Prodigy today, and I have make the double check by using a token, and I will give you a number that you have to insert in your Prodigy. Have you ever done this before? Yeah. Okay. So the number for today is 88129. Okay. Please do it right now in order to. 88129. Okay. Can we try to close them? Okay, so some instructions. Now I'm going to share the screen here. If you go, I'm going to share the screen in a second. Can you see the screen? push you. Yes. People online. Yes. Okay. Well, you go to the course page here, and you find both the connection to the folder. When you ask the folder permission, you don't have to click hundreds of times, just one. Then I get an email and I will allow you to enter. Maybe not real time, but I will do, because I received thousands of mail because people see that doesn't happen anything, so try again, and again, and I receive hundreds of emails from each person. And this is the first point. The second point is that I have activated here the form for registering for the project work. Okay, so there is a Google form here that you have to fill in. It allows maximum 3 students for each group, and for each of them you have to repeat some profiling information that I need for the reporting already. And here you have to choose between the research paper or the digital enterprise venture plan. Insert the project title, the abstract, and indicate the date of the exam. Okay. Okay. It is clear? We cannot access the form. Okay, maybe I double check it just to. Yeah, actually, you have to log in first before compiling the form. You have to log in with your Sapienza ID on Google, because it allows only people from Sapienza, so only students, registered students, to fill in the form. So it is clear. Yes, but you are not clicking the right the right link. You have to click here. Can you try here just to check that it works? Okay, so it works. There is no deadline actually. Depends on the date that you want to do the exam, but of course it should be well in advance of this date. I would say at least, but this is really the minimum, 1 month before. Okay, because then you have to present it. Okay, so what I'm expecting, if you go for a research paper, I expect something that, an activity that follows this disorder. So the identification of the topic, of course, it must be a topic that is related to the course topics. The idea about the issue that you want to face and how, yeah, so the references, so the bibliography, the literature that justify the issue that you are dealing with, that you want to deal, so which are, and justifies also the hypotheses that are at the base of your work. Then the let's say the selection of a methodological approach towards the search of the answer to your research question, because of course, according to some hypotheses, you will also draw a research question. So you will talk about the problem that you want to solve. Then you will have to write it, probably by using Word or another, let's say, commercial Word editor. But if you want, you can also use LaTeX, for example. Of course, you have to pay attention to plagiarism, and to quotation of other article that you selected from the literature. You have to draw up and make the correct references to the bibliography. Then you have to do an exercise of proofreading, and then you have to, let's say, send the paper and provide the also the presentation of this paper. Okay. If you are if you will choose the technology venture plan, you will indicate the topic. I suggest to follow then the approach of the business model canvas, and maybe someone of you already know, but we will face it in the digital entrepreneurship lessons. The business model canvas is based on 9 building blocks that we have described. Then again, proofreading and cover page, and then you will have to prepare a pitch. Your presentation will be a pitch for your technology venture. Okay, these are the say two alternatives. The keyword of the technology venture plan have to be of course digital transformation. So the usage of the technologies that we the usage of the technologies that we will meet along the course But these technologies should be applied in particular to circular economy and let's say everything that is related to sustainable development. So your challenge is to identify a way of applying digital transformation in the fields of circular economy, blue economy, and sustainable development. Okay? So start thinking about these ideas. Firstly, try identify which is, I have no preferences. You can do either the technology venture plan or the research paper. It's the same, let's say, from my perspective and for evaluation purposes. This always counts the 50% of your evaluation. Okay. Now you have to think about what you want to do, which are your group mates, and identify, of course, the work and the topic that you want to face. After having do that, you have to register in the form with your details and an abstract of your work. And of course, the date that you select and the format is tentative. It's not the only date where you can have the exam, but it's useful, especially for me, for say organizing the work. Then, if you move from one day to another one, I think I've allowed you to modify the form. Okay, so you can change the date or after having completed, or change some words, on eliminate one person from the group. Of course, it's important that the information is stable when you are close to the exam. Okay. Everything is clear? Okay. Two questions from me. Yes. Okay. So let's go to the it is strange that you can see it because everybody is seeing here from here. Are you accessing with the Sapienza? No, you don't have to access to the drive. The drive is another thing. The form is here. The link is here. I can make it in bold if you. Okay. Bold. This is what you get. Okay. You have to click here. Try to exit and enter again. Okay. Okay. So let's go to the So in the video that we projected at the end of the last lesson, I mean the Wednesday lesson, the guy in the video, he was talking about the 3Ds model. Actually, the big data are characterized by 5Ds. This is the we already know what is the meaning of volume, velocity, and variety. We know that every day there is a growing amount, huge amount of data, new data that are produced every single second. Okay, and this is the reason why data are big. We know that the capability of transmitting even large quantity of data is increasing thanks to the high-speed networks that will become faster and faster. Just think about to the fiber optics ultra broadband or to the 5G telecommunication networks that are starting to be developed. Because of course, 5G is something that is still limited to big cities, some big cities. 5G will be extremely sparse and extremely fast, many times faster than the, say, most advanced 4G technology, and we will talk about it. So velocity for transmitting data that are extremely various because data are in typical formats such as text formats, numerical formats, that were transmitted over the networks were somehow or mostly structured with given structures, very easy to manipulate. So mainly we are referring to database structures or let's say organized collections of data. With the advent of the Web 2.0 and the social networks and so on, the data that are transmitted every second in real time are in many cases extremely unstructured. Think, for example, to the sentences that every one of us write on the social networks. Of course, we use jargon, you know? We use emoticons, we use truncate words, and so on. So this kind of information is extremely unstructured. But anyway, thanks to most advanced techniques of artificial intelligence, actually, we are also capable now to use and reuse and interpret this data that, as I said, are shaped in a structured manner. Okay. In this way, we are also capable, for example, to catch the sentiment of the people that, for example, now is here in the city, in Italy, in many places, is voting. And we are capable to catch the sentiment of the voters, for example. Of course, connected partly to also to the matter of variety of the information is the matter of veracity. So not always the information is reliable. And we have to put in place, let's say, the countermeasures for being sure that the information that we get, as we said, in the characteristic of information that comes from the big data is true and reliable. After having verified all of these characteristics, we can, again, give a value to the data. And so the model becomes a 5D model. This is a Venn diagram for the people that still remember some math, where we have set and subsets of data. And which are the connections between the different types of data. Of course, as you may see, there is a strong interconnection between different typologies of data. The big data includes everything, of course. Okay, includes open data and open government data. So there are in the big data that are created themselves from companies, so private data, so non-public data, that are produced for marketing, business analysis, also national security. So data that you cannot access unless you have, of course, particular permissions. Then you have data that are in the form of open data, so data that are open to anyone, that comes from scientific research, social media, and other, let's say, non-governmental sources. For example, if you want to study the sentiment, as I told you before, of the consumers for your company, you can easily buy from Twitter the APIs for following and analyzing the timeline of your channel or some others channels in order to listen the voice of the customer and analyze it. Okay. All this information is stored somewhere. Of course, you have also in open format many data that comes from the business reporting, the official business reporting. Then you have in open data, you may have in open data the data that comes from statistics. If you go on the Eurostat website or the national statistical offices, you can find plenty of data that are available in the open floor. Okay. Then you have the domain or the subset of the open government data that we have already seen here with the last example, but might be open or not, that they come from the government, the governmental organizations. This data can be provided in, let's say, raw format, basic format, and you have also, for example, for research purposes, to reshape across this data in order to obtain your own added value. An added value that cannot be directly provided from one source of this data, just take it as it is. If you can merge data, if they are coherent between data sets, you can make correlation, you can make machine learning on this data in order to obtain, let's say, secondary data that are useful for your specific purposes. Or the other way around, you can create your primary data sets, for example, by making your own surveys for the purpose that you are dealing with. So you need to make a survey again on the sentiment of the people towards certain product, and you want to double check the survey, for example, with the timeline of Twitter and compare it. So you build your own questionnaire, you try to find a sample of person that is coherent, 1,000, 2,000, 10,000 person, and then you compare the results of your primary data sources with the timeline of Twitter in order to understand which is the right interpretation, for example, of the tweets. The new yes, I will. The new oil has a specific value chain where there is a link between the community that produces data and subjects that publish data. For example, when you go to register a new birth, you are somehow the producer of the data of your song, no? And you go to the municipality registry office and you communicate that a new baby is born on in a city at a certain date and hour, having two parents, name it X and Y. Okay, and you give this data to the municipality that becomes a data publisher. And for example, by eliminating the name of the baby, but just keeping the gender, the date of birth, and so on, may publish this data. Okay? Of course, they have to eliminate any personal information, but they publish this data and they communicate this data also, for example, to the National Statistical Office. That today the municipality becomes a data publisher, communicating the data to the National Statistical Office that can use the data either for aggregating the data and building the national demographic statistic, or, for example, the same data about the baby, in this case with the full information, name, surname, is provided to the tax offices for issuing the fiscal code and the health card. So you can see here, and you can find so many examples that the data are produced by us, are communicated to subjects that are data publishers, and reused for different purposes that can be statistical purposes or service purposes for enabling the users to have services, such as, for example, the National Health Service, after having received the health card. On top of this, there are subjects that, with the same data, produce also added value services that are not necessarily for free, but they can gain money from the the added value that they are able to generate. And this is the actual value chain of the data. Clear? Of course, having a value chain, you have a charging regimes. So basically, you can have three forms of payment. That is the paid access, the normal paid access that is based on the typical drivers of a for-profit company. So profit maximization, cost recovery, data production, cost recovery. Of course, these can be also alternatives. Cost recovery of initially establishing of data distribution and reuse, or on the marginal cost. Of course, the marginal cost in a non-monopolist regime, but in concurrence regime is equal to the price. So, and you should remember this from economic studies. Then otherwise, you can have zero price access. That doesn't mean open access by zero price. That might be subject to restrictions on use and distribution. Or, as we have seen before, you have open data. Open data that are useful, but in general are data that you have to manipulate in order to extract value from them. And this is exactly what this and this subject do with the open data. Because the open data that you get is the date and place of birth and the gender of the person. But in order to create value from that, you have to reaggregate data to extract value. It's like the oil. The oil itself, the tangible oil, the petrol, doesn't have a value. The value comes when the oil goes into the refinery, where the sub-products are created. This is the same for data. So if you think about a digital venture, you have to think how to create value from data. Of course, and this is partly true, even though this is measured in terms of perception, the perception of the user about the data is higher in relation is much higher in relation with the prices. If I pay for something, I suppose that the value is higher. If I don't pay, probably the value is lower. This is not always true. It's a matter of perception. Everything's clear? Seems clear. just a few seconds of break, just to ask you a couple of things. Why Thursday you were so few? Because also here online I see so many people. Last Thursday you were more or less the half of the expected people. Both. Personally, no, just to.
I stayed at home and I followed from home
Because
we only have this class, and for me it takes like 1 hour and a half to come
yes,
here.
yes.
So
No, but in general, the half of the people were there were 30 online and 5 here. No, just to know because to understand. Because actually only in one case you have the class colliding, that is for the Wednesday lesson. For the Wednesday lesson, some of you have the classes colliding, and for this because they belong from another degree. Okay, so they asked me of recording the class of the Wednesday, but in the other case it should be no collision. So I just wanted to investigate if there are any trouble on Thursday. Okay, just to know. So we completed this part. Now we go through quite quickly, I think. And in the second chapter of the book, yes, probably, where we talk a bit about the history briefly of the history of computing. That actually is really interesting if you want to learn more about this and go more in depth, at least for your personal curiosity. There are plenty of books that tells about the history of computing. Of course, when we talk about computing, we already consider the capability of humans of making calculations, and this is something that is needed since from the ancient times, since from Sumerians that were using these tablets for making calculations, or also I don't know how translated in English, but I'll look to the Chinese that are still using it's a kind of abacus, the abacus. Indeed. Yeah. They are still using the abacus for making calculations, and they are extremely fast in doing this calculation by hand with the abacus. You see, this is an abacus. Leonardo da Vinci was one of the first scientists. Of course, you know that he was an extremely eclectic man, ranging from science, from engineering, to paintings, arts, so music also. Maybe many people don't know that Leonardo was also a songwriter, and there are songs written by him. And this is the draw of a computational machine. Generally speaking, what was the issue, the problem of Leonardo da Vinci? Why he wasn't always able to realize his projects? No idea. It was a matter of enabling technologies. At the time that he lived, the technologies, the enabling technologies, were not so advanced, mature to support his projects. Think about the helicopter. The helicopter can, or the airplane can fly either, both, thanks to the engines and to extremely efficient materials, extremely light materials. At that point of time, the only materials that were known were the wood that is extremely heavy. No? So the problem for Leonardo was to find the right materials to allow the realization of his projects. Exactly, was too ahead with respect to the existing degree of technology. And this is one important lesson that every innovator should know. The problem of timing of the innovation. If you go on the market with an innovation too early or too late, the risk is that you fail because it's too early for making the innovation technologically supported or understood by the customer, or it's too late because someone else has already did it better than you. The timing is everything. And Leonardo attempted to design calculation machine that you will find. This is the Gunther rule that is used by the engineers. That you will find more than 2 centuries after in the Pascal machine and in the Leibniz machine. The design that these machines made by two famous mathematicians of the 17th century are really similar and similar to the design of Leonardo. These machines were capable to make calculations both addition and subtraction and multiplication and division. The frame for textile production was actually the first programmable machine. Programmable with using these cards indicated the draw. Of the product that is designed on the product. It can be wool or whatever. In the 18th and 19th century, the UK Royal Navy was one of probably the most powerful navy in the world, capable to colonialize more or less mid of the world. And the Navy had a big issue. The calculation of the ship trajectories, because of course there was no GPS, and the only references were the stars, the sun, the stars, the North Pole, the North Star, the polar star, and but this was useful only for knowing about the north and the south, but not about the east and the west. So they needed, and the calculation to be made for doing these trajectories were really difficult. So they decide to use a machine for doing this kind of calculation, and they gave the duty to develop such kind of machine to another mathematician that was Charles Babbage, that after years of research developed this kind of machine. The problem with this machine was that it was extremely heavy and not transportable with the ship. So they had to give up and continue to calculate the routes with the paper and the pen. This was an example of the first typewriters. And now this was the first commercial typewriter, that it was not exactly a calculator, but something useful for typing in a more efficient way. This is a machine that was used for making calculation in the early, until the 40s of the past century. And you can find some sample of this is still around. And of course, is a full calculation machine that, of course, is not efficient like the one we have now, but is something that allows you to make calculation in very easy. This was the first portable machine for calculations. This was you don't remember this, but these were the machines that were at the cashier in the shops. And of course, the first, let's say, producer of calculation machine was IBM, and International Business Machine, where the motto of IBM was is still every people in IBM at this desk has this motto in front of think. So we go back to the textile frame, and we have the punch card for programming, like it was in the frame, that was used till some years ago for, but not that long ago. I remember this. That was used till 90s of the past century for programming. We should still have some of this in the computer laboratory behind your shoulders. This was the first hard disk, magnetic disk, very big, with really low storage capability. Another commercial machine from IBM, the machine for producing the punched cards, tabulating machine. This was one of the first computer built just after the Second World War by Konrad Zuse, the Z3 machine. As you may see, this was built in his own house, in a room of the house, where you have clothes, you have bicycle. This is the typical example of the pioneering times of computing, such as the Hewlett-Packard garage, where the first computing machines were assembled. And now we are back to the theme of enabling technologies. Of course, the computers of the first generation were based on technologies known in that period. And so basically, what we know as the thermoionic valves. Okay. These are this kind of lamps are the thermoionic valves. Do you remember maybe in the jargon of your parents or grandparents when the light was off? Someone was saying the valve is jammed, the valve is broken. because the appliances, all the appliances, before the 60s or the last century were based on this kind of bulbs that, like the lamps, were broken. This man is John von Neumann. John von Neumann is an Hungarian mathematician that during the Second World War escaped from Hungary, Germany, and went to the United States for also participating into the physics and mathematician, for participating to the nuclear bomb project. But together with this, he made such a lot of things. For example, he developed a economic mathematical model for game theory. Maybe if you remember, you study game theory from the economics, you remember the games of von Neumann and Morgenstern. But he also developed a theoretical model of a computing machinery. He wrote a paper with a theoretical description of what data could be in the, say, a new generation computing machine. And this theoretical model is still the model that works with our computing machines. And this model probably is going to be overcome only when the quantum computing will become reality. But this is another story. By now, all the computers that we have work on the John von Neumann scheme. And we will see. This was one of the first commercial computers. As you can imagine, this huge machine, these huge machines like the ENIAC, the consumption of these machines was like a small city, the electric consumption was like a small city. And again, here you see people programming these machines directly, connecting cables, closing circuits without an interface like the keyboard and the screen that we are used to have. And the capability, the computational capability of these machines was not comparable at all with the computation capability of our smartphone. Here you can see the first programming interfaces. It is still not a keyboard or a screen, but it's a touch panel where to make connection between circuits. So as I told you, see here, the programmers were high level, high skill people. here you can find the first example of video. And you see here, this is quite emblematic because you see that you have a huge computing machine with a chair and a kind of dashboard here for governing the computing machine. Still IBM. Then we have the second generation where the thermoionic bulbs were changed with transistors and integrated circuits, smaller and with less electricity consumption of thermoionic bulbs. So these technologies allow somehow to miniaturize, but somehow, or at least produce computers that are of smaller dimensions than before. And this is also thanks to the discovery of the properties of the power that is possible to find in the desert, that is silicium. Thanks to silicium, Silicon Valley, it's possible to build circuits, host circuits, with a low consumption, lower consumption of power, because this powder, this material, has a semiconductor property. And here they start using interfaces and also, of course, fonts for representing the characters. You see also the introduction of tapes, magnetic tapes for recording the data, for archiving the data. This is still analog. See here, this was a typewriter connected to the computer in order to use it with a strange screen. Teleprinter is a kind of fax for transmitting data. Then the third generation starts to integrate these circuits into even more reduced dimension chips. So small scale integration, medium scale integration, SSI stands for small scale integration, MSI for medium scale integration, semiconductor and technologies. They start to introduce programming languages more oriented to the user. While till that period, the programmers were using so-called machine programming by using zero and ones, by closing and opening circuits. So the knowledge of the machine was fundamental for programming it. Now there is the possibility to abstract somehow from the knowledge, the physical knowledge, the architectural knowledge of the machine and program the machine without or with few knowledge of it. The first mouse and also the introduction of portable devices for storage of the data. And now here, the first Intel processor. Again, in punch cards. And you see here one of the first examples of connected computing, where the connection was made through telephone line by using a modem for connecting this telephone to another one and to the computer. Did you see the movie War Games? It's an old movie, the 80s, where the guy was playing, and this is a nice movie, it's a clever movie, was playing or thinking to play, but actually was playing with the computer of the CIA. And for connecting to him, he was inserting the mic of the telephone into a box that was the model for transmitting data. Let me check if I find this just to. One second. This is the first example and of security problem. You see the modem here? This is the modem. It thinks to play with a computer, but actually plays with the NSA, National Security Agency computer. And okay, watch the movie. Okay. I don't want to spoil the movie, so this was the first electronic portable calculator from HP. I had this. I think I have still somewhere, maybe in my parents' home, and it was amazing because it was making logarithms and exponential and trigonometry. And this is was something that one of the first, let's say, house game Pong that was a box like this, just for this one, to be connected to the television, and we were really passing hours and hours playing this stupid game. Personal computers, the first personal computer where you can see uh, the layout of the screen was vertical instead of horizontal because you read the vertical things. You are used to read the vertical things, so they thought to have a vertical screen. This was the really first laptop, portable computer. You see here a screen. It was really heavy. It was about 20 kilos or something like that, but it was portable actually. Then the fourth generation, so a growing capability of integrating transistor into the microchips, so large system integration, so to integrate even more computational power into a single microchip. So large system integration and very large system integrator. So the birth of microcomputer, the one that we use now, and also of the networking. And of course, in parallel, the development of big supercomputers capable to support science research or space travels and so on. Do you recognize someone? Anyone here? This is Bill Gates. And this is Paul Allen, the two of the founders, the main founders of Microsoft. This is another IBM. This is the first Mac with the Apple. Okay. Then again, ultra large system integration and wide system integration. The adoption, finally, the last 35 years of graphic user interfaces, the one that we use every day now, without knowing anything about the way how our computer works, how the hardware of the computer works. The introduction of object-oriented programming, instead of writing lines of code, we have the option to write object characteristics. And we say that a box that we can see can make the calculation of the square root of a number, and so on. The introduction of optical memories, and even more. And the next generation will be about the use, actually, next is here. So the use of nanotechnologies is something that is already started, and also the quantum computing has already started, even though it's still in, let's say, the research phase. And I will tell you tomorrow why we are still in the first phase and which are the implications of the introduction of quantum computing. So that's it for today. Questions?